Have you ever really thought about the invisible rules that are running your computer right now? The ones deciding who can do what? Well, today we are pulling back that curtain. We're going to explore the OS's secret world of users, permissions, and privileges. So, let's get right into it.
So let me just start with a really simple question. Who's actually in control of the files on your computer? Now, your first thought is probably, well, I am. But the real answer is a little more complicated than that. It all comes down to a strict set of rules, and it's your operating system that's the enforcer. And that's really the big idea for today. Don't think of your computer as some kind of magic box where things just happen. It's a rule book, a very, very strict one. And here's the thing. Attackers are out there 24/7 trying to find loopholes in those rules, while defenders are trying to make them ironclad. Understanding this rulebook, that's a massive step toward real security.
At its very core, this is all about digital property, right? Permissions are just the way your operating system draws lines in the sand. It's how it says, hey, this file, this is yours and nobody else gets to touch it. Or, whoa, that's a critical system file so you can't accidentally delete it. It's there to protect your data from other people and honestly to protect the system from you.
Okay, so if we're going to understand this rulebook, first we've got to know who the players are and what powers they can have. These are the absolute fundamental building blocks of the entire system.
So first up, we have the user. That's super important to get this right. A user is not always a person sitting at a keyboard. A user is just an identity on the system. Yeah, it could be your personal account or a super powerful administrator account, but it could also be a piece of software running in the background that needs its own identity to access things. And next up, we have groups. So imagine you need to give, say, 10 different people access to the same project folder. Doing that one by one would be a total nightmare, right? Well, instead, you can just create a group, let's call it staff, toss all 10 users into that group, and then give permission to the group just one time. It's all about working smarter, not harder. And this brings us to what is, without a doubt, the golden rule of managing all of this. You assign people to groups. And then you assign permissions to those groups. See the difference? You're not managing a dozen individuals anymore, you're managing roles. And trust me, this makes everything so much cleaner, safer, and way, way easier to keep track of.
All right, so we know the players. Now let's look at how the rules themselves are actually written. And it turns out there are really two dominant philosophies here. And we can see them pretty clearly when we compare the two big families of operating systems, Linux and Windows.
So on the one hand, you've got the Linux approach. It's simple, it's elegant. For every single file, you set permissions for just 3 entities: the owner of the file, a specific group, and then everyone else. And the permissions are super basic. Can you read it? Can you write to it? Or can you execute it? That's it. Then you have the Windows model, which uses something called access control lists, or ACLs. Now this is way more granular. It lets you create this super detailed list of rules for tons of different users and groups, all on the same file. You can think of it as simplicity versus complexity, and honestly, they both have their pros and cons.
Of course, each system also has its own little quirks that attackers just love to exploit. In the Linux world, a huge one is called the SUI binary. So this is a special kind of program. When you run it, it doesn't use your permissions, it runs with the permissions of whoever owns the file. So if a super powerful user like root owns a flawed SUI program, a regular everyday user could potentially trick that program into doing things with all of root's power. Yeah, not good.
And Windows? It has a very similar REST, but with its services. You see, a lot of the background services on Windows run as this all-powerful account called local system. So if an attacker can find a bug in one of those services, they don't just compromise that one program. They can potentially take over the entire machine with the highest level of privilege possible. Game over.
And that really brings us to what the attacker is trying to do. Once they get that first little foothold on a machine, maybe through a phishing email or they guess a weak password, their next move usually isn't to steal your data right away. No, their main goal is to break the rules and become the most powerful user on that system.
This whole process has a name. It's called privilege escalation. And this is the make-or-break moment in most cyber attacks. Think of it like this. It's the digital equivalent of going from being a janitor with a key to a single supply closet to suddenly becoming the CEO with the master key to the entire skyscraper. That's the goal.
And the playbook they use to pull this off is remarkably consistent. Step 1, get that initial access. Step 2, they poke around, they scam the system, looking for any kind of weakness, a crack in the rulebook. Step 3, they exploit that flaw. And finally, step 4. If they're successful, they take complete control.
So, what are these weaknesses they're hunting for? Well, we've already talked about two of the biggest ones, those misconfigured SUID binaries in Linux and those insecure overprivileged services in Windows. Some other common ways in are finding passwords or secret keys that were just left lying around in the computer's memory, or, of course, exploiting bugs in software that just hasn't been updated with the latest security patch.
Okay, so we know how attackers try to break the rules. How do we build a fortress to actually stop them? Well, it all boils down to just a few core defensive ideas.
Now listen up, because if you only remember one single thing from our entire conversation today, make it this one. It's called the principle of least privilege. It's such a simple idea. Give every user and every program the absolute bare minimum level of permission it needs to do its job. Nothing more. This is brilliant because it limits the blast radius. If one of those accounts gets compromised, the amount of damage an attacker can do is tiny because the account couldn't do much in the first place.
And building on top of that, we've got a few other key defenses. Things like separation of duties, which basically means no single person can control a whole critical process from start to finish, or just-in-time administration, where you only get admin powers for a very short, audited period of time, right when you absolutely need them. And of course, just good hygiene for service accounts, like regularly changing their passwords so old ones can't be found and abused later.
You know, when you take a step back, it all really comes down to this idea. Permissions aren't just a bunch of technical settings. They're the operating system's moral code. They define what's right and what's wrong, what's allowed and what's forbidden inside that little digital world.
So, I'll leave you with a final thought to chew on. Take a hard look at your own digital life, your own systems. Are the rules you've got in place, your permissions, your privileges, are they actually strong enough to stop someone who is actively and intelligently trying to break them? Something to think about. Thanks for joining me.